Here's a quadratic equation, and we're going to solve it with the quadratic formula. So we discover that A is 5, B is 6, C is 11. We'll plug those values into the quadratic formula as shown. And then we do 6 squared to get 36, and 4 times 5 times 11 to get 220, and 2 times 5 to get 10 in our denominator. But then we do 36 minus 220, and we get negative 184. And when we go to take the square root of negative 184, we know that we can't do that. At least not if we need it to be a real number. And for this course, we're working with real numbers. So we say there is no solution to this equation because there is no real number that is the square root of negative 184. And for short, we can use the empty set symbol to show that there's no solution to this equation. Let's take a look at this equation and show what it would have looked like if we had solved it by completing the square. We would have added negative 11 to both sides, divided everything by 5, and then taken that 6/5, cut it in half, and squared it, and added that to both sides, which is 0.36. And then we would simplify the right side to get negative 1.84. And then, since we understand completing the square, we know that the trinomial on the left can be rewritten as the square of the binomial x squared plus 0.6. And now it's time to take the square root of both sides. And just like we did when we had the quadratic formula, we can't take the square root of negative 1.84. So we stop right there and we say there's no solution to this equation. Well, here's an interesting problem. We can factor it, but it's a perfect square, so the two factors are both x minus 3. So there's only one solution. X minus 3 is 0, so x is 3. If we plug this equation into the quadratic formula, we get this. And after we do some arithmetic, we get that under the radical, it's 36 minus 36, which is 0. And it's because the value under the radical is 0 that we know that there is only one solution. Because 6 plus 0 is 6, and 6 minus 0 is also 6. And 6 divided by 2 is 3. So we've shown both by factoring and with the quadratic formula that there was only one solution to this equation. And when using the quadratic formula, we knew there was one solution because the value of the expression under the radical was 0. In fact, in the quadratic formula, the portion of the formula b squared minus 4ac is called the discriminant. When the discriminant is less than 0, there is no solution to your quadratic equation. So in fact, if you look at the discriminant first and you see that it's a negative number, you can stop and just say no solution. You might be able to save some time that way. If the discriminant is exactly 0, there'll be one solution to the quadratic equation. And by the way, that one solution will be a rational number. If the discriminant is greater than 0, there will be two solutions to a quadratic equation. And just for the record, if the discriminant is a perfect square, the two solutions will be rational numbers, and if the discriminant is not a perfect square, the two solutions will be irrational numbers.